Hello, this is a video for EDX Statistics 1. This is the third video in this series, and it will concentrate on finding critical values in critical regions for Poisson hypothesis tests. In the previous video, we considered this example about the manufacture of light bulbs and the percentage that were defective. If we change the last part of this question to ask how many bulbs would have to be defective for us to conclude that the percentage was different to 0.9%, it's the same as asking for where the critical region of this hypothesis test would be. What we need to do is decide on values at both tails which would lead us to reject the null hypothesis. So potentially equal to 0, or maybe less than or equal to 1, and potentially greater than or equal to 9, or possibly 10 or 11, or some number up there. If we consider probabilities at the lower tail to begin with, we can see that if we chose the probability x was less than or equal to 1, we would have a value which is greater than 2.5%. So our critical region at the lower tail is less than or equal to 0, or just equal to 0 really, because that probability is less than 2.5%, which is the significance level for the lower tail. If we look at the upper tail, if we were just to do greater than or equal to 9, we get a value which is larger than 2.5%. But instead, if we look at greater than or equal to 10 and add up those probabilities, we do get a probability which is less than the 2.5%. So our critical regions is either equal to 0 or greater than or equal to 10. So the critical values are 0 and 10, and you can write the critical region in set notation like this. So we would end up rejecting H0 if x belonged to that set where x is 0, 10, 11, 12, 13, or any integer value larger than that. If we want to find the actual significance level of the test, so remember that we were looking at a 5% two-tailed test to begin with, what we need to do is add together the probability of ending up in either of those two critical regions. So we simply add those two numbers together and get the value 0.0282, and that is the effective level of significance for the test. It is important to note that we're not allowed to allocate the 5% unevenly to each tail. It must be less than or equal to 2.5% at each side of the distribution. Another example of finding critical regions is here. We have a machine that produces glass sheets, and the number of bubbles per square metre follows a Poisson distribution with a mean of 5.7. We want to find both the upper and lower critical values for a 10% significance level test. And we want to find the actual significance level. So normally, if we were doing a hypothesis test, we'd set up the null and alternative hypotheses like this, and we'd be looking at a Poisson distribution with a mean of 5.7. So in order to find the critical regions, at the lower end, we're looking for a value for which the probability that x is less than or equal to that value, it's going to be less than 5%. And you can see at the lower tail that if I was to take 2 or less, that's going to be greater than 5%, but 1 or less adds up to give me a probability of less than 0.05. It's the same at the upper tail. I'm looking at the probability of being greater than or equal to 11. If I add those up, that's going to give me a value of less than 5%. But if I was doing greater than or equal to 10, then it ends up being greater than 0.05. So our critical region is both less than or equal to 1 and greater than or equal to 11. So the critical values are 1 and 11, and if I want to find the actual significance level of the test, I simply add those two probabilities together and get 0.0538. That's the end of this video and is also the last video in this series.